Covalent or molecular compounds, which involves the sharing of electrons. The oxidation states that are found on the periodic table show how sharing occurs within a covalent bond. These are not charges per se. They simply show a partial positive or a partial negative as more electrons are shared out or more are tugged on and held onto. First, name the first element followed by the second element. Second, change the ending of the second element to "-ide." And third, which is mandatory, add Greek numeric prefixes to indicate the quantity of each element type. Our Greek numeric prefixes go between 1 and 10, although you could expand that and go further. We have mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. The first element never gets mono, and the A or O of a prefix is dropped when next to oxygen, typically prefix oxide. Now, if you follow IUPAC rules, we can leave the A or the O from the prefix, but when we say it, it is often dropped. You'll notice off to the side we have the nonmetals that will be involved in sharing of electrons. We can get about 96 binary compounds that actually occur. Here we'll try 6 of them. We have PbBr5. We'll go about this systematically, and we're going to write out phosphorus because it was first. We'll come back and write bromine in a moment. Next, we've got nitrogen first, arsenic first, sulfur first, nitrogen first, and silicon first. As I said about the bromine, we'll sweep back through and add in the second. Now, because I know I'm going to have to change the ending, I'm going to remove the ending and basically allow for the IDE to be added in a moment. So I've got brom, ox, ox again, ox again, ox again, and brom again. You'll notice my choices are rather limited. I'll go ahead and sweep back through for that second step where I change the ending of the second one to "-ide." Bromide, oxide, 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 and bromide. Finally, we'll do the third step where we go ahead and we add in the Greek numeric prefixes. Since phosphorus is by itself, it does not get one. It's first, and the first one never gets mono. So we get pentabromide. Next one, we'll get dinitrogen monoxide. Next, we'll get diarsenic pentoxide. Next, sulfur trioxide, dinitrogen trioxide, and silicon tetrabromide. Notice the O and A ending of the prefix has been removed with these oxides that have monoxide and pentoxide. The trioxides were left alone. Writing a covalent or molecular formula from a name. Write the symbol of the first element and the symbol of the second element. Note the prefixes and apply the value as a subscript to the corresponding element. We'll go about this systematically. Iodine is I, sulfur is S, diphosphorus, we can see phosphorus in the name, so that's a P. Dihydrogen, we can see the H. Xenon is by itself, Xe, and silicon by itself, Si. Notice that the second letter is always lowercase. Next, we've got chlorine, trichloride, chlorine, Cl. Next, tetrachloride, Cl, pentoxide, O, monoxide, O, hexafluoride, F, dioxide, O. The iodine has no prefix, so it gets no subscript. The presence of the I indicates 1. Tri is 3, tetra is 4, di is 2, pent or penta is 5, di is 2, mono is 1, hexa is 6, di is 2. Again, notice we do not have the prefix for several of the first ones because there was only one.